So when you're differentiating something like this, you can just see that is under a square root. Everything is under this square root. So it means it's raised to the power half. And then that's why here is raised to the power half. And then we have to rewrite everything so that we are making it simple. This one is cubic root, then is 1 over 3. That's why everything here is raised to 1 over 3. And then this one is the square root. It means this one is raised to the power half. It's raised to the power half. Then now let's start rearranging. Since since everything was raised to the power of half, it means now when we're doing our chain rule, then we'll multiply, because you remember the chain rule, we start on the outside, then we go on the inside. On the outside part, then we have to minus 1 from the half, and then after we have multiplied by half, then you go to the inside one. Now we have not yet differentiated the inside part. We are just showing that no, we are differentiating the inside part. You see, this is still the first part the same way. This one is to show you that now we are going to differentiate the inside part. So what you have to note now, since the inside part is like this, it means you'll use the quotient rule to differentiate the inside parts. It means this problem is starting with the chain rule, and then inside the chain rule, now when are differentiating the chain rule, since we have a fraction here, we use the quotient rule inside the chain rule. Then now let's do the quotient rule for this one, the inside part. What is our chain rule? Our chain rule now, it says we take the second term, which is our denominator, and then we multiply it by the derivative of the first term, which is our numerator. So it means g of x multiplied by the f of x prime, then minus f of x, which is our numerator, multiplied by the derivative of the of g of x prime, which is our denominator that is already differentiated. So we are showing now we have to differentiate this one and this one, and then after that everything have to be divided by our g of x to the power 2. So now let's start differentiating. We already shown that we are differentiating this one, and then we raise the denominator to the power 2. So when you are coming here, this one now we have already differentiated. We already know that one, this one will be 2, and then this one have to multiply here. When you're multiplying here, and then when you're minusing 1 here, we are left with to the power 3. And then when we are coming into this one, as this one has to remain the same, and then we differentiate this one, differentiate this one, and then we already know, since it's half here, when you're differentiating, it means this one is already a chain rule, since it's half. So we have to multiply by half here and minus 1. Then that's why you see half and then negative half. And then since it's a chain rule, we started on the outside, then in the inside. Then we have to differentiate this one. We are showing here we have to differentiating. We are taking it step by step. That's why it has not that differentiating. But if you are making it fast, it means you're going to multiply by this derivative of this thing, which is what? Which is 2 on the inside when you have done it with the outside. Then we have to go down there. This one, this one, since it's the outside, you're just keeping it. You will see it at the end, and then you come to this one. This one already now it just needs simplifying. You see this the 3 and 3 can cancel out. You are left with 4x to raise to the to 1 over 3. Then you come to this one. You already mentioned that one will be 2. So now we have to simplify everything. So remember, if this one is raised to the power half, this thing it means it can cancel out, or if you like, you can see that this thing will be just 2x plus 5. That's why it's 2x plus 5. Then you continue with it. Now it's just a matter of simplifying and taking it step by step. So when you're coming to this step from here, or after you have multiply out and then this thing as cancel out or as made one, then when we're coming to this one, remember this one is negative half. Okay, if you take it down, you can take it down, it will become positive half. That's why it becomes a denominator. It's taken down here. Then you continue. Yeah, you just rearrange your things now, so that you can simplify it. When you look at this one, something interesting is happening here. So these things, they are the same. So if you look at this one, all of this is divided by this one, by just this one. So if you bring it this side, you can say divide. But if you already know fractions, you can say, if you want to change the division sign and and make it a multiplication sign, then it will be 1 over this term, 2x plus 5. So if it's already like this, you know, if it's multiplying the exponents, you can add them. So in other words, this one you can say 1 over uh, 2 plus 1, which will give you 3 over 2. You see, we have added these 2. That's why when we come here now, it's 3 over 2. So now it's a matter of expanding. Multiply this with this, multiply with this and this one, the same way with this and that one. And then you can realize that this one, when it's 4x, and then when you come to this side, the 4x will be subtracted by 2x. That's why you'll be left with 2x. Then you just do like that, and then you look at the like terms and all that. And then when after we have simplified it and cancel out the like terms and all that, then it comes to this. You see, yes, the exercise is long. You just follow the rules, and then you'll be fine.